Hello, everyone. Happy New Year, and welcome to the first Graph Guy episode of 2022. It's great to be back. I hope everyone has had a safe, healthy, and happy holiday season. Today, as advertised, we're going to be talking about identity and sort of what that means in terms of a modern application, how that affects our data, our business, and how, most importantly, I believe graph database technology gives us a really unique opportunity to do something that's been extraordinarily hard in the past in that space. So we'll dive into that for sure. Thank you, Mikey J, for the background. I try to switch the backgrounds up as much as possible to keep things interesting. So glad that people are appreciating that. So a few housekeeping things, as always. Still working on hitting our follower goals, and actually, we hit our first goal just before the show. So we've been working for 20 followers for quite some time now. We hit that today. Thank you. So a little bit of background too. Because we're a fairly new stream trying to get out there, get some traction in the community. Really appreciate those of you who followed us. Graph-guy.com is our website for all of our replays, recaps, and you can get all of the links to all of the videos in case you missed or want to go back to see a stream there. And for those of you who've been following, you know I have a couple of daughters, and I mentioned I really need to get some followers to convince my daughter that their dad's Twitch stream is at least vaguely cool. Well, I discovered over the holiday break that, as with is the case with many teenagers, they never really heard me say I have a Twitch stream, even though I've said that. And so I had their attention at one meal. They were like, "Whoa, Dad, seriously, you got a Twitch stream? Where is it? Let me go look at it." And I was immediately bombarded with a whole bunch of critique and notes and things, as only teenage girls can do. And not surprisingly, they are far more Twitch sophisticated than I am. So I have pages of notes and tips and critiques and things from them. So that's going to play into effect here. And we started implementing some of them already. So goals, right? So for 20 followers, we're going to upgrade PuppyCam. So again, if you've been around, you know we've got puppies here, 2 German Shepherds. We had PuppyCam for a while. PuppyCam went away. PuppyCam is back now, but blue, and I don't know why it's got a blue filter to it. But at 20 followers, which we have hit today, I will be upgrading PuppyCam for the next show, so that we get rid of the blue and get better views of the puppies when they make an appearance, as I am sure they will today, as one is already at my feet. So 25 followers is our next big goal, and we'll do a special episode. I'll put a poll out there. I've already shared some recipes with you all in the past. We can do a cooking with Graph Guy show. This will be a special episode at a different time, so you will not lose any true technical content, or potentially, we could do a different type of a show. I also while I'm not a professional dog trainer, I spend a lot of time working with professional dog trainers, doing some training on my own. And we could do maybe a dog training episode, or, again, I'll put up the poll. I'll give you an option of, please save us, don't do any of the special shows, just stick to graph stuff. So that'll be an option too. But 25 followers, that's our next milestone, and we'll do a special episode during the week at some particular point in time. And of course, that will be recorded as well in case you can't make it live. If we can get to 30 followers, this is the big one, then I will actually bring my daughters on board in some part-time capacity as my actual Twitch managers, because they have so many things that they want to implement and do to help. And I've put some of them already sort of into place here. So we'll see if that does help us get to up to 30 followers. That would validate a lot of the things they've been asking or telling me I should be doing. And then we'll kind of put them in the hot seat and give them a little bit more control over how we do some stuff here, and see if that helps. So get to 30 followers. Maybe this becomes a little bit cooler through some teenage influence and a little bit better managed. We'll see. So those are our administrative goals. So let's get to our actual technical content for today. Good news, bad news. I'm going to be doing some drawing again. So those of you who've seen me do this in the past, this can be dicey. So identity, right? Let's talk about that for a second. Obviously, identity is important, both in the technical side and in the business side of things. So on the technical side, right, regardless of what kind of a database we're using, the database needs some way to identify the essentially atomic structure of data we're looking for. So in case of a relational database, that might be a row. A document database, it would be a document. RDF database, it would be a triple. Graph database, it would be an entity, rather a node or an edge, right? So some way internally they have to know that. So again, it could be a URI for a document database, a primary key for a relational database, or it could be, so again, so for there we go. So for our identity, we'll get better at this. So this could be a primary key for relational. It could be a URI, perhaps for a document database. If we're dealing with an RDF database, that's probably an IRI. For a labeled property graph, that just could be some sort of internal ID. Might be a numeric ID, something like that. But there has to be some way to essentially to figure out internally, what is it that we want to look for, right? What is that record we want to retrieve? So that's certainly important as a technical constraint for any kind of a database, and that's fine, right? So these are technical constraints. There we go. But these have driven a lot of what's happened in sort of our thinking about identity. And the good news is, for many of our business problems in the real world, that's okay. That is more than sufficient, right? If we think typically about, products, if we have a retail application, they probably have a SKU, right? For example, we have a SKU. So let's say customers often get like a loyalty ID, right? So like I sign up for your loyalty shopping cart, I get an ID so you know who I am. I've got that unique ID in the real world. Phones and emails, those are pretty obvious, right? My phone number is unique and email is unique. In terms of like social media, we've got, those also enforce some kind of unique username by platform, right? So it becomes easy to identify things. So all of this type of data pretty well can be mapped into these technical constraints, right? If I know that product is identified by a SKU, well, that's easy to represent in my data and deal with technically. Same thing with the customer ID or social media username, an email, a phone number, etc. Even an address to some degree, right? You could use something like a latitude and longitude, or you could, depending on the level of granularity you're interested in, use some combination of street address, secondary street address, and zip code to identify a location. And again, for most cases, this works well. But in reality, as we go deeper into a lot of these domains, it turns out that identity is not nearly as straightforward as we would like it to be. So I'll give you several different examples there. One of which is, surprisingly enough, is SKU. So I'll change colors here. So it turns out that for a lot of companies, a given product, so let's say you're selling some sort of a pen or a marker set, right? So you've got some sort of a marker set. I'm getting better at this. Oh, I say that just as I go. Let's see, does this, does not delete. That's okay. I was hoping that would erase. So it's kind of a marker set, right? And we would think that there is a SKU that uniquely identifies that. So I go into the store and I buy this marker set, there's some sort of SKU, it appears on my receipt, and that is the SKU for this marker set, and that's identified. However, and let's say this happens, in store. What happens in a lot of retail scenarios, not everyone, but in a lot, is if I purchase the same marker set online. So when I say the same marker set, I mean like if I brought the two of them together and I put them right next to each other, they look absolutely identical. Right? There's no distinction between them. Companies give those a SKU as well, but those SKUs are not the same. So same exact physical marker set, two different SKUs. And the reasons companies will do that is the original thinking often goes along the lines of, I want to be able to understand which markers I'm selling online and which markers I'm selling in person, so I can better track the channel, what is selling via which channel, and so forth. The problem is now arisen that for a lot of companies, they want to just really understand, well, how many of these marker sets did I sell? Do I need to buy more? Or what are all the metrics around this? And there's no internal tracking that says this SKU is the same as this SKU. They're completely separated internally to the company because the data sets are completely separated. The online product set and marketing and sales is completely separated from the in-store processes, and they have no way to join these things together. And it becomes a major, major problem. Other areas that comes in, certainly, we said social media, we have username, but what if on my website, so I've got a website, and this could be an e-commerce website, it could be whatever. So if I allow you to log in via social media and view things or make purchases or whatever I want to do, I have a Facebook account, I've got an Instagram account, I've got a Twitter account, etc. Back in the day, I had a Google Plus or whatever it was account. Multiple customers or viewers can have more than one social media account. So if I log on once with my Instagram and once with my Facebook, how do you know that those interactions made by each of those separately, apparently different users are really the same, that they're both really me? That becomes really, really challenging to do. And this generally becomes a problem with people. People becomes one of the hardest things to identify, right? How do I identify a person? We almost never in an application have an SSN, a social security number. Very, very few domains have that. And even in those that do, not everyone actually has a social security number. And if you're in a domain that does have that, this becomes very restricted information, and how you deal with that is often subject to regulatory compliance and so forth. So it's tough to do. So you think about SSN, well, you can't really use phone number, even though we are in the days of the prevalence of mobile phones. People still have landlines. People still use shared mobile devices. The phone number that is given for a person might also be used by another person. It might be that someone's coming in with a work number and it's a trunk line. So phone number doesn't work. Name is a nightmare. And I say this as someone who's spent many, many years supporting our U.S. government defense and intel communities and trying to figure this out. There has been millions and millions and millions of dollars spent in technology trying to figure out, are two names the same, particularly as you deal with sort of English-based names. So you deal with names from German or Arabic or any of a variety of other languages. It becomes really difficult. But even just in English, right, you face the problem of, is John Smith, if I sign John Smith, and that should be an I, is that the same person as J. Smith? is the same as John without the H, Smith. People will spell their names differently. Is John J. Smith the same as John Smith? If I have the middle initial. Sometimes I use my middle initial, sometimes I don't. And these could all be typoed, right? Especially if we have manual entry going on. If these accounts are created and someone mistypes their first name, it can be a nightmare to deal with. And so when we are forced by our technology into picking essentially a single value for an identity, there are many domains here, as you see, where that becomes problematic. We're not able to do a really good job of identifying what it is we're talking about, whether it's a product, a visitor to a website, or a customer or some other type of person that we're trying to identify, because identity cannot always be distilled down to a single property or value. It's often an amalgamation of things that allows us to really determine how do I identify this specific thing. And that's not something that a lot of these traditional databases, relational, columnar, document-based, etc., really allow us to do very well. So what you end up with is essentially duplicate identities within your data. So for example, I've worked with a number of retailers, and of course they'll give customers a customer ID. And you'll work with that, and they'll tell you that it's unique. And it is. There are no two customers with the same ID field in the data. But when you ask them, well, how did you identify that? You start getting a lot of sort of puzzled looks and hemming and hawing. Like, well, we outsource of data to another company, and, we send them like a terabyte of customer data, and they come back and they give us a number for every customer. You're like, okay, well, what is your confidence in that? And they go, yeah, it's not very good. We know it's not very good. We absolutely know. And I've worked with some very large retailers that there are unique people in the database that have multiple customer IDs and that they think are the different customers, because this algorithm is not very good. Why? Again, because it's typically, again, trying to come up with some unique single value based upon that. And this is where graph really provides us a cool opportunity to do better. So let's look at what I mean by that and get you away from my horrible drawing. And whoopsie, let's go this way. No, I gotta go over here. So many things that I'm not doing well. It's okay. All right. So here I am in, once again, my Neo4j web console. Let me make it a little bit bigger again, so it is not an eye chart for everyone. Hopefully we can work at this resolution okay. And I've loaded an extremely simple data set, so that this becomes really easy just to follow along. This is obviously not representative of real data, but I wanted to show you something that's really understandable. So what I did is I loaded up some people and places and addresses and so forth. So let's take a look at this. So I'm just going to return that. Let's make this bigger. Okay, so this is all of my data. So I've got I have person and place and phone number and email. This is my entire data set here. So we see I've got 3 different people in the database. I've got John. I've got John with an H, and I have someone whose first initial is just J. In a moment, I'll click on these in the non-full screen mode, and we can see a little bit more detail on them. This represents the entirety of my data set. And what I want to do is understand, are any of these the same person? So again, we see that each of them has at least one address where they live at. They have a phone number. They have an email address. So a fairly normal consumer type of data set. So if it's smaller again, and we look at the person, we can see, yes, here we have someone whose first name is John and last name is Smith. They've got an age. Another one, J. Smith, and then John Smith. And again, they have emails and so forth. So we can make this a little smaller in here. There we go. And we'll move things around to fit in the screen a little bit better so people can see things. And lovely. Okay, so how can we do this in graph? So the beauty of graph is a graph lets us easily see all of the relationships associated with an entity, such as a person, and then do analytics on that to understand those relationships. And again, this is a very simple example here. We've got 3 potential relationships off of these, or these relationship types. There could be multiples of those. A person could have multiple phone numbers and multiple emails, for example, but 3 potential types. And now, because we're in graph, I can start to use this information to determine, are these people the same? So how would I do that? Well, there's something we've talked about, I think, a little bit here in the past. There's an algorithm called weakly connected components. And what weakly connected components does is it's an algorithm that goes through all of the data in your database, and it finds groups of data, connected components, whereby everything in the component can, if you start with any particular node in that cluster, if you will, then by following the relationships from that node, I can get to all the other nodes in the cluster, right? So for example, if I pick this particular phone number and I follow this relationship, I get to John, and I follow John, I get to here, and then I can get to this email as well. And these 2 nodes don't link to anything other than John. So this would be one cluster. And then this would be another larger cluster where, again, if I picked any particular node in here and I walked all of the relationships until I hit all of the entities that were available, again, a fairly typical algorithmic graph walk, I hit all of those nodes. This would be a separate cluster of data. And of course, in a real data set, you'd have many of these different types of clusters in varying shapes based upon your actual data. It's called a weakly connected components because I can follow these relationships in any direction. So again, if I want to start at phone, I can follow phone to the person here, John, even though, whoopsie, I deleted him from my view. Even though, it's a little bigger, even though as we see here, the relationship is actually defined as starting from John and going to phone number. So John has phone. In a weakly connected algorithm, I can walk that in either direction. If I wanted to do a strongly connected components, that would instead imply that the direction of this relationship is really important, and I only want to follow that in one direction. That's not the case here. I'm saying we can do weakly connected components. So that will give us 2 different clusters. So let's pause there a second and talk about how can we find this? Because we're just looking at the data here, it's easy to find these components, to see them visually. But when you've got a graph database with potentially billions of nodes in them, you obviously can't just pull them all up on your screen and look at them and go, oh, I have these particular clusters because I can see them. You have to be able to algorithmically find those clusters. So how do we do that? Well, we're fortunate in that Neo4j has this wonderful graph data science library. And we're on the documentation for that page here, clearly. So weakly connected components is an algorithm that is a subset of the larger category of community detection, right? Finding communities of entities. So there's a whole bunch of information on this page. But the good news is essentially that there is an or a simple cipher function you can call against the database. We provided some parameters such as what node types are you interested in your community. You can exclude certain node types, what relationships you may want to exclude against certain relationship types. I'll talk in a minute about why you might want to do that. And then what this algorithm will do is it'll go through all of the data in the graph. It'll find all of those clusters, and it'll identify them and give the cluster itself a unique ID. And then you can define kind of how you want to deal with that. One of the most straightforward ways is to have the algorithm essentially write that ID back to every node in that cluster using a property that you define. So maybe you say cluster ID, and then as it goes through, it'll assign a cluster ID property to each of those nodes that it finds in every single cluster. And this is a very, very rapid algorithm. I've run this algorithm on Neo against databases of hundreds of millions of entities, and had this run in like a second or less on not very large hardware. So again, it's very, very well done. I will give you one tip if you are working specifically in Neo with this. If I can find it in here, there is there's a configuration you can send in here. And if I scroll down far enough here, I will show you the configuration, which is let me find it again. There's a configuration option in here. I've got to find memory estimation, streaming, so I'll find them all. But basically, you can tell the algorithm specifically that you do not care what the direction is. Basically, tell it to might be in here. So strings tolerance. I'll find it. We'll post it back on the. We'll post it back on the website. But basically, you can tell it again that when you're doing the walk to create the graph, go ahead and do it without persisting the direction of the relationships, and you get a significant increase in terms of the performance on that. So I'll find that. I'll post it back to you. It just escapes me where it is in this page right at this particular moment. There's a lot of information actually on here. Maybe it's down here. Yeah, we'll find it later. So just a little tip there. So back to our actual data. So I could run that weakly connected clustering on my data set here. It would identify these two clusters, and then would update each of these particular nodes with the cluster ID property and value. So this might be cluster 1, this might be cluster 2. So now every node in cluster 1 would have a property called cluster ID with a value of 1, and every node in this cluster here would have a cluster ID with a value of 2. So that's a great start, as I found those clusters, and that can often be the hardest thing to do in terms of performance. So now the question becomes really, right, and when you define that cluster, of course, what you want to do is make sure you're defining clusters of customers. So when you enter node types, you want to have node types of customers, and you want to make sure that you choose relationships that make sense in terms of identity. So for example, if I had transactions in here as well, retail transactions, so I had that John, made a purchase to some product, so I'd make purchase or makes transactions, relationships coming off of John, I would probably not want to include them in terms of cluster identification, right? Because if I buy a product, let's say those markers we talked about, and you buy that product, well, nothing about that transaction is indicative of the fact that we may or may not be the same individual. It really has no bearing on that. Now, if we wanted to look at product recommendations, whole nother story. That's a different application for this. But in terms of identity, the products that we buy do not define who we are as a person, and that's probably a much larger philosophical statement we can make about that. So we want to really pick things that help us identify. In this case, people, or whatever is interested in identity. So I've chosen here, where do you live? What is your email address? What is your phone number? Right? These to me probably say that if I know where you live and your phone number and your email, and maybe I have social media accounts or other things, but again, to keep it simple here, I've used those 3 types. If I have information about that for you, I can probably start to make a pretty good determination about who you actually are with that data. So again, bear that in mind as you're using the algorithm to create or find these clusters. So I found the clusters with the information I care about. We've written a property to them. Now what I really care about is I only care about the clusters that have more than one person in them, right? Because there's only one person in the cluster, like here with this John. Well, by definition, there is nothing in my cluster, in this case, again, address, phone number, email, that would lead me to believe that John has more than one identity in my data, right? There's no one else with the same address, email, or phone number as John. So John is just John. There seems to be very little chance that I have another person in this set that is really the same as John. So I'm not interested in this cluster. So what I do then is now find all clusters that have more than one person, or whatever the thing again I'm looking to identify is. So that leads us here to cluster 2. And then the trick is, right, you want to go ahead and look to see, okay, for every person, in this case, to keep it simple, just 2, I want to count, first of all, how many things are in this cluster that are not people, right? Because those are essentially the data points, the relationships that I'm using to identify things, right? So I've got to have an email relationship here, a lives at, a phone number, another lives at here, a phone number, and then email. So we've got 6 relationships essentially here. And 6 relationships, and I've got 1, 2, 3, 4 different entity types that are not people. So how do we process that, right? So if I look at this just, as a person, I can say, okay, let's make this a little small so you can see the values again. I can say, okay, look, John, let's give it a large, I guess. So this particular individual lives at the same place as this individual, and they have the same phone number. They have different email addresses, but they have the same phone number. Like, there's a pretty reasonable chance that these are the same person. Now, if they had the same email address as well, I would definitely feel more confident. So if there's a relationship from this person to this email address as well, I definitely feel better about it. But here I feel pretty good. So how do we encode that, right? So really what I'm looking at, if you think about it, is so this particular person, again, is connected to 3 of the 4 things that are here. This one's also connected to 3 of 4. There's an overlap of 2. So instead of the 3 things that they're connected to, 2 of them are the same. That's a pretty strong correlation. It's not perfect, but it's pretty strong. Now, obviously, what does pretty strong mean? You have to determine that on your own. But you can start to do some math now and come up with a quantitative number that says, this, for example, seems that these 2 individuals seem to be the same, by about 66% or so. They're about 66% of the identifying relationships in this cluster that we cared about. And so with that information now, you can start to build out an algorithm that lets you go through and either fully automate it, if you like to live a little dangerously, and perhaps the results are not super critical, like maybe it's marketing, something like that. Or you can put human eyes on it, which is typically my preferred approach. But again, depends on your scale as well, to say that, okay, these 2 are the same, and what I really need to do is merge them down into one node that has all of these relationships, because I don't really have 2 different people or 2 different customers here. I've actually got one, and that somehow have gotten misidentified. And so, in this way, using these types of graph algorithms, you're really able to look at a much broader spectrum of data points in order to make some determinations on identity and doing identity disambiguation to figure out, are these two products the same? Are these two individuals the same? Are these views to my web? Are these anonymous hits to my website actually coming from the same person or not? Maybe again, that could be looking at IP addresses and device types and browser types and so forth. So not it's not magic. There has to be some sort of algorithmic intent and figuring out what these thresholds are and what are these identifying relationships. But you're now given a set of tools, or at least you can go ahead and you can start to perform these analysis in a way that really just wasn't possible when we're just looking at data points tied to a specific thing, as we're often forced to in relational and other type systems, where again, walking out all these relationships, particularly for the entire data set, would be really just far too cumbersome, would not perform, etc. So real high-level entry overview into doing some identity analysis, identity disambiguation with graph. As always, I look forward to your questions. Please hit me up either on the website, graph-guy.com. You can hit me up on Twitter as well, at @CRichui, RICHUI. Really looking forward to your comments, questions, thoughts for other topics, other guests you might like us to have on the show. Please spread the word. Help me get some more followers. And I look forward to seeing you all again soon. And as always, I'm Clark Richey, and I'm the Graph Guy. Take care.